circular trig unit, finding the exact values of a trig function using the unit circle and the Pythagorean identity. You can find the example problems in your IBSL textbook on page 201. Here are some formulas for you to remember. The Pythagorean identity is sine squared of theta plus cosine squared of theta equals 1. And then the quotient identity for the tangent, remember, is sine of theta over the cosine of theta. Here's our unit circle. Remember the 4 quadrants and the sine and cosine pieces of these ordered pairs. Remember that this is a positive quadrant, negative, positive, negative, negative, positive, negative. So on the next slide, it just kind of breaks down the signs for each of those quadrants. To review with you, to find trig functions of any angle, we focused on a circular trig where you have your angle theta. Then you have a radius, and then you could drop down a right triangle here. This distance across here is x. And then if we are in this second quadrant, this would be a negative x value. And then this distance going straight up is our y value. And we taught you some trig functions. To find the sine of theta, it's y over r. So the cosine of theta is x over r. The tangent of theta is y over x. And then the next 3 are the reciprocal identities. What we're going to do on the next example is go back into the Pythagorean identity and find the exact value of the cosine of theta if we're given the sine of theta is 2/3. So we're going to substitute in the sine of theta, which is 2/3, into the Pythagorean identity. So 2/3 squared plus cosine squared of theta equals 1. Now we can solve this equation for the cosine of theta by undoing. So first we'll square the 2/3. So 2 times 2 is 4. 3 times 3 is 9. And we still have cosine squared of theta equals 1. Next step is to subtract 4/9 from both sides. So 1 minus 4/9. Then we're going to convert that 1 to a 9/9. So we can subtract those fractions. 9/9 minus 4/9 is 5/9. And then the last step is to undo the squared. So you remember how you undo a squared is you square root both sides. So the cosine of theta equals plus or minus the square root of 5/9. Now remember, we were given the sine of theta is 2/3. So down below, if you look at 5/9, I can break up that square root of 5, and then square root of 9 is just 3. And we have plus or minus. So we will have a positive x and a negative x here for cosine. So what 2 quadrants do you get a positive 2/3? Here is my 2/3. There is my 2/3. So to find the exact value, the cosine of theta is plus or minus the square root of 5/3. Next example, given that the sine of theta is negative 3/4, and this angle now has a restriction, the angle is going to fall between pi and 3 pi over 2. So here is pi, here's 3 pi over 2, our angle is going to fall in the third quadrant. So there is our theta. If we construct a right triangle, this would be my x, my y, and my r. We're going to use the Pythagorean identity again to find the cosine of theta. So we will substitute -3/4 in for the sine of theta. So -3/4 squared plus cosine squared of theta equals 1. And this will help us to find the first piece of the cosine of theta. So -3 times -3 is 9. 4 times 4 is 16. Subtract 9/16 from both sides. Change the 1 to 16/16. 16/16 minus 9/16 is 7/16. Then we want to undo the squared, so we're going to square root both sides, plus or minus the square root of 7/16. I can then reduce this radical to 7. Square root of 7, square root of 16 is 4, plus or minus. Now, remember that they give us now a restriction of our angle has to fall between pi and 3 pi over 2. If we go back to this third quadrant, remember our sine is going to be our negative. Our cosine also has to be negative. So one of these solutions doesn't work. So we can only have the cosine of theta being negative square root of 7 over 4. Then the next piece, after you know the sine and the cosine, you can use your reciprocal function, or your quotient function in this red, of taking the sine over the cosine. So cosine is negative square root of 7 over 4. The sine was given to us in the original problem as -3/4. So now we have a fraction over fraction, -3/4. Reciprocate and change. So 4 over negative square root of 7. The 4's will cancel. The negatives will cancel. We're left with 3 over the square root of 7. We rationalize it. Square root of 7, square root of 7. Multiply across. 3 square roots of 7 over 7. Now we know the tangent. Here is the example in the book. We don't like it, the example the book does not rationalize here in this problem.